Hello, this is David Scher's review for the second exam for CSC 260, question 2. So question 2 is write a mem file for default.u code. So we're going to talk about default.u code. So remember, I put up on Blackboard all the opcodes for default.u code. And I'm going to show you them in a second. But make sure you bring your opcodes list in to the exam so that you don't have to be trying to do this from memory, because I can't do it from memory. I doubt you can either. It has, now we're going to have the location of array in position 100. Here we see 150 is the location of the array. The size of the array in 101. This is saying it's 3, and it's going to eventually put the largest byte in the array, that's the largest number in the array, in position 102. So if the mem file has 100, 150, 101, 3, 102 minus 1, and then 150 has 7 minus 6, 4, that's the array, the program will replace the minus 1 in location 102 with a 7. So now let's scroll down a little to where question 2 starts. Now the first thing is I have the list of default opcodes. So I use this when writing the code. There are 16, there are really 15 real opcodes, and then there's no up and halt. And you might be able to remember them all, but why? You can just look at them. It's open book, open notes. Now, what I did is, rather than write the code in front of you and watching me stumble through all sorts of little syntax errors and so on, I just wrote it and got working all in advance. So we could talk about what the correct code looks like. Okay? Now, in this thing, you always put the memory location. So I started the code with the array. I made a little array of size 5, 7, minus 6, 4, 9, minus 2. That way, as as tracing through, I can see if this thing really works or not. And then there's the array starts at 150, its size is 5, and 102 is minus 1, just like in the other one. Now, in this code, the first thing I do is load 100 into R0. That will then, I'll get out from 100 to 150 the array location, and that ends up in R0. So R0 is going to hold the location of the array, and that's going to be consistent throughout the code. Okay, I'm going to get the number from 101 and stick that in R1. So R1 is going to have the array size. You see, first I load 101, the constant into position 1, and then I get from position 1, the 101, I get the actual data there. So that array size we're going to be messing with, because I'm going to keep decrementing it until it becomes 0. Now R2 is going to hold the largest so far. The first thing I'm going to do is take from position 0 R2 and shove it into R2. So there we see R2. By the way, a little bug. Originally there was a bug in my code. I had a 2 there. I have to remember to keep thinking in binary throughout, and that can be hard. Okay, now starts the loop. The loop is going to go through all the code. Okay, so I'm going to decrement R1. Okay, so that's the array size. So each time I go through the loop, I decrement, and if it gets to 0, that would mean that there's 0 things left in the array and that I haven't looked at yet, and that will, and I can stop. So here I check for 0, and I jump to 18, if it's not not equal to 0. And okay, so I check for 0. If it's 0, I jump here, and that'll take me to 32, which is the part where I store the largest into the 102. So, okay, that says jump to record largest, and that's what it does. So I jump to 18, I jump over this. Now I'm going to get the next array location, put it in R0, and get the next array item, and put it into R3. I'm going to subtract R3 from R2. If negative, R3 is larger, and loop. If, okay, it's not larger, basically. So now I'm checking. So it puts the result in R3. Now I'm checking R3. I'm going to skip if negative. So this is going to be, so if it's positive, if subtracting from R3 from R2 was positive, that means R2 was larger, and we can just go back to the beginning of the loop. Otherwise, I got to replace the R2 with the new larger element. Now, what's in R3 is R2 minus R3, and it's negative. What I want to do is create the original R3. There's the new larger number. So what I do is subtract it from R2. If you read the math right, R2 minus R2 minus R3, minus and minus the plus, ends up with R3. So I do that arithmetic, and I do a subtraction and put the result in R2. So now R2 is updated, and now I loop. So either way, I loop. So I keep going until I get through all the items in the array, and then I'll jump down to here. Here I take 102, load it into memory. This is the process always to read or write memory. First we use the constant, and then I put R2 the largest, and then finally I halt. And that is the answer to question 2. Now, you can't do this during the exam, but I never really trust code unless I've actually succeeded in running it. So, what I can do is I'm going to just show you that it really works. I have written this guy. I have default.u code. There's default.u code there. And I have this code you just saw was copied from a mem file that's called reviewq2.mem. So if I run this, okay, and we can watch as I load. Okay, so now I'm loading the location of the array into R0, and then I'm going to load, so that's 100 in R0, and then I'm going to load 150 into R0. You can see it looks like a negative number, but it's really the unsigned 150. Now I'm going to put in R1. Once again, in R1, first I put 101, and then I put the array size, which is 5. Now, I'm going to put the first item in R2 in the array. So I'm going to grab once again, let's go back. The first item in the array is 7. So I'm going to put 7 into R2. You see 7 got into R2 there. I'm going to keep going. I'm now somewhere heading into the loop. And we're going to see, we're going to get negative, I think that's negative something, or negative 6 or something. Keep going, we subtract, it's positive, 7 stays in R2, and R1 gets smaller. We read another number. Keep adding into R1, and okay, we're getting to the point here where I just loaded 9 into R3. So that says I sorted 9. Now this is a larger number, and that's a negative in R3. That tells me. And now I'm going to go to the place where we skip over loop. Instead, we're going to load 9 into R2, and you see R2 has just become 9. So, as you see, when it's smaller, it doesn't update it, like we're going to see now. When it's larger, it does. And if I run it to the end, and we take a quick look at memory, the real thing, and we scroll down to 102, we'll see that the 9 has been placed in 102. So the thing really does work. And I'm not going to run through a full set of tests, but that shows you the thing works pretty much. So that's the answer to question 102.